Hello, it's Keith here, and this is lesson 25 of the simple series of my 6502 assembly programming tutorials. Now we're back on the Atari Lynx today, and we're looking at bitmap drawing again, and you can see something that looks pretty similar to the previous bitmap example, but now we've got some sprite clipping, so our sprite can go partially off the screen. The other thing we've done is we've actually double buffered it, so there's now two screen buffers, and while we're drawing one, we're showing the other, so there's no flickering while we're doing this. So we're going to look at this example today. Now we're not going to be looking at the joystick reading routine because that's exactly the same as the previous time we looked at this example, so please see my other simple series example for how to do that. What we're going to look at today is the sprite clipping code and also the screen buffer code, which to be honest isn't very long anyway, it won't take very long. But first of all, let's start by discussing the logical units that I'm using in these sprite clipping tutorials. Okay, so the problem we've got, at least on most systems now, it wouldn't be so bad on the Lynx, but I'm doing this in a way that's compatible across all of my systems. But basically, what I'm working in is a coordinate system from 0 to 255 on the X and Y axis, so both axes are a single byte, and we need a visible screen in the middle of the screen and then an invisible area around the side so that our sprite can be partially on and partially off the screen. As I say, I'm designing this to work on all systems in a common way, and a lot of the systems have got a 256 by 192 screen. So how do we do this? Well, what I'm doing is I'm using logical units that are effectively pairs of pixels. So our movements can only be a minimum of 2 pixels in either the horizontal or the vertical axis. Now, the Atari Lynx screen is actually pretty small, so this possibly wouldn't really be necessary for this system, but as I say, a lot of this is about making something that's compatible for multiple systems so that I can reduce the amount of work taken for porting to more systems. So that's how the logical units are going to work, but the other thing we need to discuss is the concept of how we're going to crop these sprites as they move around the screen. So let's go over to the blackboard and let's take a look at that. Okay, so let's start off by creating ourselves an imaginary screen. So if we imagine that that is our screen, and it's not very well drawn, but it'll have to suffice, and then we're going to have some kind of sprite on our screen. And our sprite is going to be in a box, and the box, parts of it might be transparent or something, but we're going to always work on a sprite within a box. And then our sprite will be moving around the screen, and when our sprite moves around the screen, we'll be drawing it all, but when our sprite goes off the screen, we're then going to have to start clipping it in some way, and the way we'll have to clip it will depend on which side of the screen it goes off. For example, if it goes over the top of the screen, we're going to have to remove the top, and we're going to have to set a new start position for the drawing of the sprite and a new height of the sprite. So that's if it goes over the top. But if the sprite goes over the left-hand side of the screen, the procedure is going to be very different. We're going to have to change the width to this. We're going to have to skip this part of the first line of the sprite, but after each line of the sprite has been drawn, we're then going to have to skip this part before the next line is drawn as well. Now, of course, that's on the left-hand side, but then once again, the right-hand side over here would be different again. This time we're starting from the first pixel. We of course need to change the width, and we also need to skip this part after each line of the sprite has been drawn. Finally, of course, the sprite could be at the bottom of the screen. This is going to be very straightforward. All we need to do is change the height of the sprite, and then of course we're just skipping this part here. Finally, of course, there is the possibility that the sprite could be in the corners and over two sides. The original Chibi Akamas couldn't actually do that correctly. There's a bug in it. It didn't work. So the version we've got today can do that. I've improved my programming a little bit over the years, so hopefully it's a bit better today. Anyway, let's go over to our code and let's take a look. Okay, so here's the code, and you can see at the start here we're defining our screen, and we're defining the number of logical units that make up our screen. Our screen is going to be 80 logical units wide and 51 logical units tall. Now this is for a 160 by 102 pixel screen, so that's the logical units that we've defined. We've got some 0-page entries we're using here for various temporary values here. The letters don't have any particular meaning apart from the fact that they're clustered into pairs. Now here is at the start of our screen buffer code. So basically we now have two screen buffers. One is going to be at memory address B800 and the other is going to be at D800, and basically one is going to be shown while the other is going to be drawn, and this flip will toggle between the two, and it's very straightforward. Basically we have a single byte, which is our screen buffer here, and we EOR these two bits of that screen buffer, and that will flip between a D8 and a B8, and then all we're doing here is to show one of them to the screen, to make one of them the visible screen. We are writing a 0 to FD94 and then writing the screen buffer value to FD95. Now, whenever we want to draw to the screen buffer, we just need to load our HL pair. We need to load the H part from that screen buffer value, which will be the next screen buffer which is shown to the screen. So here's the clear screen routine, which clears hexadecimal 2000 bytes of the screen, which is one full screen. And we're using that in our drawing routines as well as the screen buffer that we're currently drawing to. Very straightforward, very easy to do. So that's what we're doing. Now, we're not going to go over the joystick reading routines. We've covered them before. I'm quite bored of them, and hopefully you are too. And if you're not bored of them and you don't know how they work, please see the other simple series examples where I've covered them. The draw player routine has been upgraded, and that's what we're going to look at today, because before it would only show a sprite if it was entirely on the screen. So what we're doing here is we're loading the bitmap address into the IY0 page entry pair. So that's the source bitmap. We're loading the width and the height in logical units. Now the sprite, the Chibico sprite, is 48 by 48, but in logical units it's 24 by 24. So we're loading that into HL, and we've also got the position of the sprite in B and C. So B and C are the XY position, HL are the width and the height. These are all in logical units, and we've got a routine called doCrop, which will convert the logical units into a byte position horizontally and a line vertically. If the sprite is completely off screen though, it will set the carry flag so that we know there's nothing to draw. We'll have a look at the drawing routine later on, but what we're going to look at first is this new doCrop routine here. Here's the doCrop. So basically what we're going to do is we're going to take the y-axis followed by the x-axis, and we're going to calculate any cropping that's required and make any adjustments to the height and the width and also the bitmap source, so that when we start drawing we draw the right amount from the right position, and that will do everything for us. So first of all, we're loading y with 0 here. Y is 0 throughout this routine, so sometimes when we need to 0 something, we'll transfer y to do that. And we're setting sprite hclip to 0. Now this is for that function, as I said before. There will be cases where our sprite is partially off the screen like this, that we need to remove this part, or when it's off the other side of the screen, and after drawing each line we need to remove this part, and that's what that sprite hclip is going to be doing for us. So we're going to see that later on, but for now it's just been started off as 0 just in case it's not needed anywhere else. Okay, so what we're doing now is we're taking the y position of our sprite and we're loading that into the accumulator, and then we're subtracting the first visible pixel of the logical screen, and we're seeing if that has caused any kind of borrow to occur, and if it has, then that means our Chibico sprite is partially off the top of the screen and we need to do some kind of cropping. So if that's the case, we're negating the new y position, because that's basically the number of pixels we need to take off the top of the sprite. We're then comparing it to the height of the sprite, and if it's over the height of the sprite, then the sprite is basically entirely off the screen. And if that's the case, we're jumping to this all off screen routine here, which sets the carry and returns, and the drawing routine will give up in that case. If it's not all off the screen though, we're storing the new amount we need to remove from the top in the 0 page entry E, and we're setting the new y position to 0, and we're storing the updated position into ZC. Now this will either be 0 if we've cropped, or it will have had the first logical unit position removed from it, so it's now one step closer to being a line position on our screen. So we've done the top there, now we're going to do the bottom. So what we're doing is we're taking the new position of the sprite, we're adding the height, and we're comparing this to the logical height of the screen. And if this has overflowed, then our Chibico sprite must be partially off the bottom of the screen like that. So once again, we need to do some cropping. So we're seeing how much we need to crop, and if it's all of it, then the sprite must be completely off the bottom of the screen. We're storing the amount to remove from the bottom in ZD. So ZD is the amount to remove from the bottom. ZE is the amount to remove from the top. Okay, so we add these two together and we see if the result is 0, and if it is, then there's nothing to crop. But if it's not, then we need to change the sprite height. So we're negating this, adding it to the height and updating the height of the sprite, still in logical units at this stage. Now, we've updated the height, but if we need to remove lines from the top of the sprite, then we need to actually update the first byte of the source bitmap accordingly. So we're loading the number of lines to remove, transferring that to the X register here, and then we're loading the width of the sprite. We're shifting this to the left once, and this is to calculate the number of bytes in each pair of lines, because remember the E register was in logical units in pairs of lines. So we've now got that. We're then basically doing a very crude multiplication here. We're repeatedly adding the number of bytes here for a pair of lines, and we're repeating this for the number of lines we need to remove. Now this isn't very efficient, but remember this only happens if the sprite is partially off the bottom of the screen, and it only happens once per draw, so this is not a very frequently occurring thing, and it wasn't really worth improving in efficiency. Most of the times hopefully our sprite will be in the center of the screen anyway and won't need any cropping. Okay, so that's cropped the height of the sprite. We now need to do the same for the width. So we're resetting D and E because they were just temporary registers for our calculations. We're now getting the X position, and we're going to do the same. So we're subtracting the first visible pixel horizontally in logical units, and we're seeing if we're partially over the left hand side of the screen. So basically we're seeing if our Chibico character is somewhere like that. If the Chibico character has gone over the screen, we're then comparing that, we're negating it and comparing it to the width of the sprite. If the sprite is completely off the screen, there's nothing to draw, so we give up. Otherwise, we store the amount to remove from the left-hand side. We zero the X position because we're drawing at the far left, and we update the X position, whatever happens. Now we're going to compare to the right-hand side. So once again, like before, we add the width, and now we are going to compare to the width of the screen in logical units, and we're going to see if anything needs to be removed. And we're basically checking to see if the sprite is in this kind of position here, over the right hand side of the screen. If the sprite is over the right hand side of the screen, we're again checking to see if the sprite is entirely over the right hand side of the screen, and if it is, we're giving up. But if it's not, we're storing the new amount to remove from the right hand side in ZD. So ZE is the amount to remove from the left, D is the amount to remove from the right. We're then adding those together, seeing if there's anything to remove. If there is, then we're going to update sprite hclip, because whether the sprite is on the far left or on the far right, we're going to have to skip some bytes after each line of the sprite has been transferred to the screen. That's what sprite hclip does for us. So now we've done that, we update the new width of the sprite in ZH, and we're going to see if there's anything left of the sprite. If there is, then we're going to update the width of the sprite, and now what we're going to do is take the amount we need to remove from the left hand side of the sprite, because if the sprite is off the left hand side of the screen, the first few pixels over here aren't actually ever going to need drawing, so we need to skip those from the source data like we did with the top. So we're taking the number of logical units to remove, which is also the number of bytes coincidentally, adding that to the IY pair, and that's now updated the correct starting position for the sprite drawing. Okay, so all we need to do now is convert our logical units into physical pixels. Now, coincidentally, because our screen on the Atari Lynx is 2 pixels per byte and each logical unit is 2 pixels per logical unit, our X position and our width are actually already in the correct format. So all we need to do is double up the height. So all we're doing here is we're doubling the height in the Y position by shifting them to the left ones. We're clearing the carry to tell the calling routine that there's a sprite to draw, and we're returning. Okay. So that's how we crop our sprite. This crop routine is basically the same in all of these tutorials, and I'm using it an even more generic one in some later tutorials on tile maps, which will be fun. So it's a good little routine that seems to work at least reasonably well. Okay. So if we get to this point, then we've not returned, so we've got something to draw. We've got a get screen pos routine here, which calculates the memory address destination for drawing, and it's based on the simple series one. It's just using a different screen memory bases depending on which of the two buffers we're drawing to. Now what we're doing here is we're loading Y with the width of the sprite, and we're going to transfer all of the bytes for one line of the sprite from the source bitmap in IY to the screen destination in DE, and we repeat until we've drawn the entire bitmap here. And then what we're doing here is we're transferring the amount we drew to the screen, and we're adding that to the source bitmap address, and then we are updating that. And then what we're doing next is we're seeing if there's any bytes we need to skip from this drawn line of the sprite. Now if there are, we're going to add those as well, and this has now updated the sprite so that it's got the next drawing position for the next pixel that we want to actually draw to the screen. We're moving the VRAM destination down one line, which is hexadecimal 50, and we're just adding that to the DE pair. That updates us ready for the next line, and then we're just repeating until all the lines of the sprite are drawn to the screen. And that's the routine that we've used today. So it seems to work reasonably well. I'm not saying it's the best routine in the world, but it's at least a serviceable example if you want to try some clipped bitmaps. Now, of course, the important thing to notice with all of this is there's a lot of work involved in all of this. The sprite drawing routines are more complicated. The calculations of the cropping is more complicated. And with Chibi Akuma's on the Z80, there were actually multiple sprite drawing routines, and some could do transparency, some could do cropping, and some couldn't do either. And so the trick was to use the correct one depending on the situation of the sprite you needed to draw. So use the faster ones when the sprite's entirely on the screen, use the cropping one when it's partially off the screen, and so on. So that's something worth considering. As I always say, please go to my website and download the source code for today's example, and you can do whatever you want with it. Make the best of it. If you've liked what you've seen, please like and subscribe. There'll be more Atari links coming later on, so hopefully you'll stick around and see that. Anyway, thanks for watching today, and goodbye.